All right, let's move on to problem number 2. So you're given a few things. You're given that RAY equals 20 kilonewtons. So I'm going to label that right now, 20 kilonewtons. RDY is 12 kilonewtons. And again, just because we haven't talked about it recently, newtons is a measure of force in SI. Kilonewtons means 12,000 newtons, 20,000 newtons. It's kind of like saying 20,000 pounds. SI is a measure of force. All right. You're also told there's no horizontal reaction, so essentially Rax is 0. AB and AG is what we're solving for, so AG is this one, and AB is this one. All right, how do we start this off? Well, we're going to do a free body diagram, and we only need to do it of A because we only need to solve these two members. If we had to solve the whole thing, then we had to do a method of joints for most of these joints, but this is a simple problem. We're going to start with the free body diagram, so that's A. How many forces are on A? Well, we have one known force. We know there's a known force of 20 kilonewtons. We also know that there's AG and AB. We're going to assume both are in tension, and we know there's a theta. Let's solve for that theta. So one thing we got to be aware of is in solving this angle, I'm going to have to go ahead and, in order to treat it like a right triangle, I have to create that angle bisector, drop it down the middle, and realize that this is 1 meter. So if this is a right triangle here, then the adjacent angle is 1 meter. The hypotenuse is 2.5 meters. SOHCAHTOA tells me that adjacent and hypotenuse is related to cosine. So I know that the cosine, actually second cosine, first I'm going to check that I'm in degrees. I am. Okay, great. Second cosine, so the inverse cosine of 1 over 2.5 is equal to 66.4. I'm going to store this value. However, I'm going to just write down for my reference 66.4 in my notes. All right, great. So 66.4. Then what am I going to do from here? Well, I'm going to break AG into its X and Y components. So let me grab at least a different colored pen. I'll do black. And I'll break AG into AGY and AGX. All right. Then I'm going to say the sum of the forces in X equals 0. The sum of the forces in Y equals 0. I don't have to do moments because you don't do moments at the method of joints because it's all the forces are acting on the body, so the distance is 0. All right, so I'm going to go ahead and circle all the X forces. AGX, AB, and that's it. Yeah, so AGX plus AB, both are pointing right, so I'm going to make them positive, is equal to 0. I don't know either, so I can't solve any of those. Y, how many Y forces? I'm going to go ahead and in black, I'll box those. There's AGY. There's the 20 kilonewtons. And again, that's it. All right, so that makes it easy. So AGY plus 20 kilonewtons, because we're assuming both are up, is equal to 0. AGY will equal negative 20 kilonewtons, which tells me that in reality, AGY is equal to 20 kilonewtons in magnitude, but instead of up, it was pointing down. So I'm going to redraw the vector AG. Now that I know AGY was 20 kilonewtons down, that tells me that the sense is down, which tells me that this vector for AG is actually pointing into the joint, and that the AGX component is actually pointing to the left. So I'm going to put a little negative here, all right, right off the bat. Now, AGX I can solve for, and I can solve for AG too, using trig. So why don't I start off by solving for AG? Okay. So what do I know about AG? Well, I know that if this angle here is the 66.4 degrees, and that I have opposite and hypotenuse, then I'm dealing with sine. So the sine of 66.4 degrees is equal to 20 kilonewtons over AG, opposite over hypotenuse. I solve for AG by multiplying by AG on both sides, and then dividing by sine of 66.4 on both sides. Again, I'm doing a little bit of fast math, trying not to spend too much time on the math part of the video. And then I'm going to get that, I'll write it out. Ag is equal to 20 kilonewtons divided by sine of 66.4. And then that's going to equal, so 20 divided by sine of second answer equals 21.8. So Ag equals 21.8 kilonewtons, because that's the unit left, right? I know that the way I solved this, Ag was pointing downwards towards the joint, which means that it's in compression. And I know its magnitude now is 21.8 kilonewtons. Now that I know Ag equals 21.8, I could solve for Agx. So let's do that. Agx, how would I solve that? Well, I know the tangent. I'm just going to use tangent. Let's just keep what I know, 20 kilonewtons. Tangent of 66.4 degrees is equal to that 20 kilonewtons over Agx, opposite over adjacent. And then when I do the math, I'll just write the answer because I did it separately. 8.7 kilonewtons, I knew it was to the left, right? So now I can plug this number in, negative 8.7 kilonewtons plus AB equals 0, AB equals 8.7 kilonewtons to the right, which means it was pointing away, which means it was in tension, and this magnitude is 8.7, and that's my answer. Awesome. Well, if you have any questions, please come see me. Otherwise, that's problem 1 and 2.